In this video, we're going to talk about graphing absolute value functions and their key characteristics. So first, let's make note of some transformation rules. So for our first transformation rule, we look at the number in the front of the function. So our basic form of an absolute value function is y equals a times the absolute value of x minus h plus k. When there's a number in the front, we call this a. It could be called any letter, but we consider the number in the front to have a certain effect on your function. So if a is positive, then it opens up. It's kind of regular. And if a is negative, it opens down. And a better way to say that is it reflects over the x-axis. That's a more formal way to say that it opens down, and that will apply to all functions later on, so it's good to know it using that terminology. Now, another rule with a is if the absolute value of a, so not the fact that it's positive or negative, but just the value of a, if that's greater than 1, it causes your function to have a vertical stretch by a factor of that number. And if the absolute value of a is between 0 and 1, then it will have a vertical compression. Or shrink is another word they use, but compression is used more often, so we're going to write that down. For the next transformation rule, let's look at h. So h is inside this grouping symbol, and it will always be considered the one inside of the grouping symbol. It doesn't matter if they call it h or they call it another letter. It's always the one inside the grouping symbol that makes your graph shift left or right. So if you have a plus h, it actually makes your graph shift. Let's write that down. Shift left. And if you have a negative h, it makes it shift right. And it's by however many units the value of h is. So if it was minus 3, it would shift your graph right 3, for example. But we're going to look at some examples in just a minute to put all that together. Our k value, which is always behind, or it doesn't have to be behind, but typically it is behind the grouping symbol, but it's outside your grouping symbol and it's added or subtracted. And it looks like its rule. So when you have a positive k, it shifts your graph up. And when you have a minus k, it shifts your graph down. And again, it doesn't matter if they call it the letter k. It's the number that's outside the grouping symbol that's being added or subtracted. A is outside your grouping symbol, but it's being multiplied. So that's the difference between the a and the k. And then h is inside the grouping symbol. Okay, so we're going to take a look at 3 examples below. Let's type in the first one into Desmos. Notice I've already got Desmos pulled up. You could pull it up on your cell phone. It works really well on cell phones. Or you can pull it up on your laptop in another tab. All right, so I've got number 1 typed in. All of these things are pretty simple to find, and now we have our transformation rules to help answer the other part of this question. So our vertex is where our graph looks like it goes from decreasing to increasing, or from increasing to decreasing, depending on what your graph looks like. So our vertex is -1, -3. It comes from the h and the k. So your h is actually -1, and your k value is actually -3. Your x-intercepts, there are 2 of them in this case, so let's write those 2 down. We have -2.50 and 0.50. Just write them just like Desmos shows them in an ordered pair format. Then let's move those. We don't want to confuse them with the next part. Your y-intercept crosses the y-axis. So let's write that one 0, -1. Okay, so let's go ahead and sketch our graph. Let's see. I'm going to use dark purple. So let's put our vertex, I'm going to put that one in pink. -1, -3. I'll just coordinate the colors the way I wrote it out. So the vertex I plotted in pink, and the x-intercepts I'm going to put in purple. So -2.5 and 0.5. And then you can just sketch a decent looking V-shaped function, just like you've seen before. Now we want to describe the transformations of the function. So I want to use the same colors I used at the top. So A I wrote in blue. I'm going to circle the A in blue. A is equal to 2. If A is equal to 2, that's larger than 1. So this function is going to have a vertical stretch by a factor of 2. And you just have to write all that out. There's no short way to write it. Okay, so let's look back over here at the H. H we put in red at the top. H makes our graph shift left if it's positive and right if it's negative. So in this case, it's a positive 1 is the way it shows up right there. So it's going to make my graph go left 1. So H was equal to positive 1, so it's going to make my graph go left 1 unit. And I don't need to write the word unit, so we'll just write that as left 1. And then K makes your graph go up or down. So K is minus 3. Let's just write K equals negative 3, and it makes my graph go down 3. All right, so that is it for number 1. Let's do another one. So let's type in number 2 into Desmos, just like it looks. So put y equals 1/2 the absolute, we gotta scoot over first. Put the absolute value of x minus 1 plus 2. Okay, so let's pick out our vertex, which is 1, 2. So notice that is the same as your h and your k value up there at the top. Your x-intercept, if you look at this graph, it does not have any x-intercepts because it does not cross over the x-axis. So we'll put none, or NA is okay. And your y-intercept, just click on where it crosses the y-axis, and that is 0, 2.5. Okay, so let's plot our graph using some of these points. So go to 1, 2 to put your vertex. Let's go to 0, 2.5 to plot the y-axis. And then something you can do within your Desmos screen is click on that little gear and click on your table. And up pops a whole bunch of points you could use to plot any graph you need. And so let's just use the point, let's say 2, 2.5. So 2, 2.5 is right there, just on the opposite side of the vertex, which makes sense because absolute value graphs are symmetrical. But if you ever need help, you've got the little table as part of your function. Okay, so now let's describe our transformations. So remember, A is the one that makes it open up or down and have a stretch or a compression. So A for number 2 is 1/2. So A equals 1/2, which makes it less than 1 and greater than 0. So it has a vertical compression by a factor of 1/2. So I'm going to show you something. Let me see if I can get this there we go. So I go back to normal, type in your parent function. Our parent function is the one that has no transformations. So it's just y equals the absolute value of x. And notice from your parent function in blue to the purple function, the purple one looks like it's more compressed or it's wider than the parent function. But that's a good thing to do when you're typing these in, is you can type in your parent function and just compare the two. Okay, so let's look at H. H is shifting left or right. That's our left or right. So H is -1. Remember, it kind of does the opposite of what you think. So if H equals -1, it's actually going to shift our graph right 1 unit. And then K is the number out back, usually. Just outside, it's being added or subtracted. So K is equal to 2. And it makes our graph go up 2 because it was +2. So that's it for number 2. Let's look at one more example. All right, so let's clear out what we've got typed in. Let's put y equals negative absolute value of x plus 2. plus 2. All right, so your vertex, again, is where your graph changes direction. It goes from increasing to decreasing in this case. Notice it's your h and your k value. And we can pick out our x-intercepts. Let's just take the vertex off of there. -4, 0, and 0, 0. And then I like to remove those and pick out the y-intercept with no distractions. So notice it is the same as one of the x-intercepts, but that is perfectly fine. Now let's graph this. Let's plot the vertex first. I always like to do that one first. -2, 2. It's like our center point of our function. And then -4 is an x-intercept, and 0 is another x-intercept. And then draw a nice V-shaped graph. Okay, so let's describe our transformations, starting with A. A, in this case, is negative, and there's an understood 1. That's your A value. So A is -1. We would say that that reflects over the x-axis, and you can tell it's reflecting because the function is facing down. But remember, it's a better way to say it when we say it reflects over the x-axis. Now, A is just equal to 1 for its value. So if I said y equals the absolute value of x, my parent function, you can look over here and tell that the purple parent function and the green transformed function are both the same width. One does not look more wide or more narrow than the other. So that's because A is just equal to 1, and then it's negative, so it made it reflect over the x-axis. Okay, next let's look at the h value. So h is inside the grouping symbol, and it's +2. So if h equals +2, it makes our graph go left 2 units. And k. K is also +2, but k makes our graph go up or down. So in this case, it's going to go up 2. Okay, so hopefully those 3 examples will help you get started on graphing absolute value and picking out your transformations and some key features of the graph.